I was thinking about this the other day. When we think about monumental feats of engineering, like, let's say the Golden Gate Bridge, or, I don't know, the Burj Khalifa.
Oh, right, yeah. Massive physical structure.
Exactly. There's this, underlying comfort in the absolute rigidity of the math there. I mean, you calculate the wind shear, you determine the tensile strength of the steel, you pour the concrete to a very precise specification, and the structure just stands.
Right.
It holds the weight. It's totally measurable. You can literally point to a massive steel cable and say, with complete empirical certainty, that is why this bridge does not collapse.
Yeah, because it's a deterministic system. I mean, you put a specific input in, and you get a highly predictable output.
Right.
Physics doesn't, change its mind halfway through the commute because it got distracted by a push notification.
Exactly.
Yeah.
But then you step into the architecture of the digital spaces we inhabit for, 10, 12 hours a day now?
Easily.
Right. The apps on your phone, the enterprise software you're forced to use at work, the checkout flow on an e-commerce site. Suddenly, that comforting, deterministic engineering mindset is just completely useless.
It really is.
We aren't building for the immutable laws of physics anymore. We are building for the incredibly murky, completely irrational, and frankly volatile landscape of human psychology.
Which is exactly why digital architecture is in many ways arguably more volatile than physical architecture.
Oh, absolutely.
Because you're designing a system where the primary structural load isn't gravity, right? It's human cognitive capacity, it's attention span.
Yeah, that's a great way to put it.
I mean, it's the user's emotional state at 2 p.m. on a Tuesday when they're, trying to reset a password while holding a crying toddler.
Oh man, we've all been there.
Right. And if you don't design for that specific chaotic human variable, your digital bridge collapses just as catastrophically as a physical one.
And that chaotic variable is exactly what we are dissecting today. So, welcome to the deep dive, everyone. Our mission for this conversation is to completely demystify the invisible architecture of the digital world that you interact with every single day.
Yeah, we're really getting to the foundation today.
We are stripping down how websites and applications are built from the absolute ground up. Starting from the raw, unpredictable psychology of the human user all the way down to the systemic logic and the literal code that makes the experience run.
Because we spend the vast majority of our waking lives navigating these interfaces, right? Yet the intense, rigorous behavioral science that dictates why a specific button is placed exactly where it is, or why a menu transitions the way it does, it remains completely invisible to the person actually using it.
Totally invisible.
It feels natural, but that natural feeling is actually the result of exhaustive, manufactured empathy.
Manufactured empathy. I like that. And today's roadmap for uncovering that empathy is pulled directly from a really phenomenal foundational resource. We're looking at Chapter 15 of Graphic Design Reference plus Specification.
It's a fantastic text.
It really is. And before we get entirely lost in the weeds of cognitive load and asynchronous data transfers and all that, just a quick reminder for you listening. If you want to follow along with the source material, or if you just want to keep a brilliant physical reference guide on your desk, you can scan the QR code right on your screen or just hit the book link below.
Highly recommend having a physical copy, yeah.
Same here. And of course, if you find yourself totally rethinking how you interact with your phone by the end of this conversation, make sure to subscribe to the channel so we can keep bringing you these deep dives.
Absolutely. So I think setting the stage here really requires us to define the actual materials we're working with, right?
Yeah, we need some definitions.
Because when we talk about digital design, we are just instantly flooded with acronyms. UX, UI.
Oh.
They get thrown around in boardrooms and pitch decks as if they are totally synonymous, Just interchangeable tech buzzwords for, make it look pretty.
Right, which is honestly the fastest way to completely derail a product from day one.
Completely.
The source material here draws a hard, non-negotiable line between user experience design and user interface design. Let's start with UX, because it functions as the overarching ecosystem.
Yeah, the big umbrella.
Exactly. UX is the study of how users feel about an experience. It's evaluating the ease of use, the perceived value of the product, and how efficiently a user can actually move through a series of tasks to achieve a goal.
What's fascinating here is that the definition really hinges on that word feel.
Right.
And that is a radical departure from the traditional software engineering of the 80s or 90s. Back then, success was simply defined by, does the program compute the data without crashing?
Just, does the floppy disk work?
Exactly. But UX evolved directly from a paradigm shift that we call user-centric design. It fundamentally reoriented the entire development process away from like the limitations of the database or even the personal aesthetic preferences of the designer, and it anchored it entirely on the psychological and functional needs of the end user.
Okay, let's unpack this a bit. So within that massive ecosystem of UX, which includes information architecture, content strategy, user research, you have the discipline of user interface design, or UI.
Right, UI is just one specific part of UX.
Right, so the UI is the combination of interaction design and visual design. It's the actual tangible set of tools provided to the user so they can navigate the online experience.
So it's the buttons, the sliders, the typography hierarchy, the transition animations, all the surface level tools.
Yeah, and let's pull away from the tired restaurant analogies people always use for this.
Oh, please, yes.
You know the one, right? UI is the plate, UX is the food. I hate that one because it doesn't capture the interactivity at all.
It's too passive.
Right. Think of it more like the cockpit of a commercial airliner. The UI encompasses the physical dials, the digital screens, the shape of the yoke, the tactile resistance of the throttle. That is the interface.
That's a great way to visualize it.
But the UX is the holistic experience of flying the plane. Like, can the pilot quickly read the altimeter during severe turbulence? Does the layout of the warning lights cause cognitive overload during an emergency?
Exactly.
You can have a beautifully designed, sleek set of UI dials, but if the pilot can't parse the information in a split second to avoid hitting a mountain, the UX is a catastrophic failure.
And that distinction is just paramount because it highlights how beautiful UI cannot rescue a flawed UX. It just can't.
No amount of polish saves a bad layout.
Right. And building that cohesive cockpit involves a highly structured pipeline. The text actually outlines 5 distinct phases of UI design.
Yeah, let's walk through those.
So first is user research, which serves as the discovery phase. Then sketching, wireframing, and prototyping, which form the core design phase.
Okay, so discovery, then design.
Right. That's followed by visual design, then usability testing, and finally user interface development, which is where the actual code gets written.
You know, the scale of that pipeline really implies a massive team. Like, you'd assume there's a dedicated researcher, a dedicated wireframer, a separate visual artist, and then this isolated coding team.
Oh, in an enterprise environment, absolutely. You will find highly specialized experts siloed into every single one of those bullet points.
Just doing one specific job.
Yeah, exactly. But the reality for startups or, smaller organizations is often just a single individual functioning as what they call a unicorn designer.
Right, the mythical unicorn who does everything.
Yeah, they're wearing every single hat, from conducting the initial psychological research to literally pushing the final CSS to the server. But here's the thing, regardless of the team size, skipping any of these phases introduces immense structural risk to the project.
Which brings us to the very first phase, right? Discovery. Because you cannot build a functional cockpit if you don't understand what the pilot is actually trying to accomplish, or, honestly, more importantly, what is currently frustrating them.
Yes, frustration is key.
User research is the engine of discovery. It's an active, continuous process aimed at uncovering the real, often unarticulated problems of potential users.
Unarticulated is really the operative word there.
Yeah.
Because users usually don't know what's wrong. The source material highlights 3 specific methods for extracting this data, and the first one is ethnographic research.
Okay, ethnographic research.
Yeah, this is a qualitative method where researchers observe people working in their natural environments. So you aren't bringing them into a sterile usability lab with 2-way mirrors.
Right.
You are literally sitting in their chaotic office watching them use their actual devices with all their normal distractions.
Now, let me play devil's advocate here for a second, because from a business operations standpoint, ethnographic research sounds like a logistical nightmare.
Oh, it's incredibly expensive and time-consuming.
Right. If I'm developing a SaaS product intended for a global market, observing like 3 mid-level managers in a cubicle in Chicago is mathematically insignificant. Why would I spend the time and capital to physically deploy researchers when I could just blast a highly targeted, standardized digital survey to 10,000 potential users globally and get massive quantitative data in like 24 hours?
This raises an important question, and it's one business stakeholders ask all the time. But the reason is that quantitative data at this stage is often a complete mirage.
A mirage. How so?
It tells you what is happening,
Yep.
but it rarely tells you why. And more importantly, surveys rely on self-reporting, which is arguably the most flawed data set in human psychology.
That is very true.
People are notoriously terrible at accurately describing their own behavior. They will tell you how they wish they acted or how they think you want them to act.
Like when they check the box that says they read all the terms and conditions?
Precisely. Or, they report on a survey that a specific software task takes them about 5 minutes. But if you utilize ethnographic research and you actually sit next to them at their desk, you witness a completely different reality.
What do you actually see?
Well, you see them open the software, realize they forgot their incredibly complex password, open a hidden Excel spreadsheet where they dangerously store all their plain text passwords.
Oh no, the dreaded password spreadsheet.
Yeah. They copy it over, encounter a formatting error, and then finally get in. And then you see them furiously minimizing and maximizing windows to cross-reference data because your interface doesn't display it concurrently on one screen.
You actually see the friction.
Yes, you see the friction that they've become entirely blind to. The primary benefit of ethnographic research is uncovering underlying problems the users themselves don't even realize are problems anymore.
They've just accepted it as part of their day.
Exactly. They've developed these elaborate muscle memory workarounds. A survey will never capture a user squinting at a screen or, sighing in frustration before clicking a button. Observation bypasses the user's filtered narrative and captures the raw mechanical truth of their interaction.
Wow. Okay, so ethnographic research is your deep qualitative dive into microfriction. But you still need to understand the macro environment, which is where the second method comes in. Focus groups.
Right. Focus groups.
The text describes this as a moderated discussion with a group of demographically similar potential users.
Yeah, so focus groups are less about observing behavioral mechanics, like we just talked about, and more about gauging conceptual value. You are exploring the target audience's thought processes and their decision-making frameworks.
It's higher level.
Exactly. It's a space to test the waters on broad value propositions before you commit to granular design work.
But focus groups have their own psychological pitfalls, don't they? I mean, you get groupthink. One loud, charismatic participant can completely skew the feedback of the entire room.
Oh, absolutely. Which is exactly why the third method is arguably the most critical for deep, reliable insight. And that is user interviews.
User interviews.
These are one-on-one, face-to-face discussions guided by a designer or product manager. And the text notes a highly specific constraint for these interviews. It says they should be focused on just 5 to 7 key topics.
That feels incredibly restrictive to me. If you have somehow managed to get a highly valuable target user into a room for an hour, the instinct is to interrogate them about every single feature you plan to build.
Of course it is.
Why artificially limit the conversation to just a handful of topics?
Because cognitive fatigue destroys the quality of your data.
Oh, interesting.
Yeah, if you treat the interview like a rapid-fire checklist of 40 different features, the user is going to get exhausted. They will just default to shallow, binary yes or no answers just to get the interview over with.
They just want to leave the room.
Exactly. By restricting the agenda to 5 to 7 topics, you force the conversation to become open-ended. The interviewer isn't there to validate a predetermined feature list, right? They are there to guide a deep exploration of the user's workflow.
I see.
And that allows the user to organically surface pain points that the design team hadn't even conceptualized yet.
So synthesizing this discovery phase, ethnographic observation shows you the reality of the user's physical environment. Focus groups gauge the broad market appetite, and user interviews dive deep into the specific psychological pain points.
That's the perfect summary.
So you exit this phase with a mountain of complex, often contradictory human data, and the challenge now is translating that psychological data into digital architecture, which transitions us into the design phase, part 1, sketching and wireframing.
And this is where the process becomes just wonderfully counterintuitive.
Oh, so?
Well, you have all this highly sophisticated data regarding cognitive load and user behavior, right? And the initial tool used to synthesize all of it is a whiteboard and a dry erase marker.
It's so low-tech.
It is. The text explicitly highlights sketching as a fast, low-fidelity way to conceptualize the interface.
That phrase, low fidelity, is just so important here. In a modern tech company with access to incredibly powerful vector graphic software, defaulting to literal pen and paper seems archaic. But it's actually a deliberate psychological strategy.
It is a strategy of inclusion, primarily.
Yeah.
And rapid iteration. High-fidelity software creates a walled garden.
What do you mean by a walled garden?
Well, if you open a complex UI design program, only the trained designer can operate the tool. But sketching democratizes the entire ideation process. A product manager, a marketing director, or even a database engineer can grab a marker and draw a box on a whiteboard to communicate an idea.
Anyone can draw a square.
Right.
And beyond collaboration, there's a distinct analytical advantage to stripping away the visual polish. When you can't rely on a gorgeous gradient or a beautiful typographic scale to make an interface look appealing, you are forced to evaluate the raw structural integrity of the layout.
It forces prioritization.
Yeah.
Because if you only have a black marker, you have to decide what the most critical element on that screen is, and you draw it the largest. It strips away all the aesthetic noise and focuses entirely on content hierarchy and user objectives.
And then once those initial whiteboard sketches solidify into a general direction, they are translated into wireframes.
Exactly.
The text describes wireframing as the structural blueprint of the experience. It defines what goes on a page, where it goes, and why it goes there, and it deliberately ignores fonts, colors, and branding.
Think of it as the schematic for our aviation cockpit analogy from earlier.
Right.
We aren't deciding what color the warning lights are or what material the pilot seats are made of. We are deciding the spatial relationship between the altimeter and the throttle. We are determining the functional flow.
Making sure they can actually reach the throttle.
Exactly. And crucially, you don't wireframe every single possible state of an application. You design key structural templates that will dictate the architecture of the rest of the system.
The source material actually provides a really rigorous set of rules for effective wireframing. The foundation is obvious, right? Understand the user goals and business goals before drawing anything. But then it introduces constraints that seem kind of at odds with the rough draft nature of a wireframe.
Like what?
Well, for instance, it insists designers must work in actual pixel dimensions. If this is just a structural blueprint, why does the literal pixel count matter at this stage?
Because spatial context is everything in UI. If you are sketching on an expansive whiteboard, your brain subconsciously utilizes all the available space.
You just spread out.
Right. You might design this elegant, sprawling navigation menu because you have a 6-foot canvas in the conference room. But the reality is that interface might need to function on a 13-inch laptop screen.
Oh, wow. Yeah.
If you don't constrain your digital wireframes to the actual pixel dimensions of the target device, you create a completely false sense of spatial relationships. You basically design a structure that simply cannot exist in the real world.
It's the equivalent of an architect drawing a floor plan for a massive kitchen without realizing the physical plot of land is only 20 feet wide. You are designing a fantasy.
Exactly. The constraints breed functional reality. The text also advises using web-safe fonts at this stage to prevent stakeholders from getting distracted by fancy typography.
Keep it boring so they focus on the structure.
Yes, and maintaining a strict grid system to ensure underlying mathematical order and meticulously tracking revisions. Because a wireframe is not a precious piece of art, right?
Right.
It is a disposable hypothesis meant to be debated, torn apart, and rebuilt.
Because it is infinitely cheaper to erase a line on a wireframe than it is to rewrite 1,000 lines of back-end code later.
100%.
And the text lists several industry tools that facilitate this digital blueprinting, software like Visio, Omnigraphal, Balsamic, and Adobe Fireworks. These tools allow you to establish that rigid structure.
Yeah.
But, a blueprint is inherently static. You can look at the floor plan, but you can't walk through the hallways. To truly evaluate if the cognitive flow makes sense, you have to inject interactivity. And that brings us to the second half of the design phase, prototyping.
And prototyping is the inflection point where theoretical structure becomes an observable experience. You take those static wireframes we just talked about, and you link them together using interactive hotspots.
Okay, so it's clickable now.
Exactly. When a user clicks the area designated as a submit button, the prototype instantly loads the wireframe of the subsequent confirmation page.
So it's essentially a digital flipbook. The experience is incredibly simplified. There's no actual database processing the information, but it provides enough of an illusion of functionality to observe how a human will actually navigate the spatial logic.
And the benefits here are massive. First, it provides a tangible, interactive deliverable for business stakeholders. It's incredibly difficult for an executive to look at 50 static wireframes and accurately conceptualize the user journey.
Their eyes just glaze over.
Right. A prototype allows them to physically click through the proposed product.
Here.
But the most fascinating benefit highlighted in the text revolves around the psychology of feedback.
Okay, here's where it gets really interesting, because this is perhaps my favorite insight from the entire source text. It points out that the in-process look of a prototype actually encourages honest feedback, because users and stakeholders don't have to worry about hurting the designer's feeling.
It is a brilliant exploitation of social dynamics.
It really is.
Think about it. If a designer presents a high-fidelity visual composition, complete with pixel-perfect shading, beautiful custom photography, precise alignment, the stakeholder subconsciously registers the immense labor that went into it.
It looks expensive.
It looks finished. So if the stakeholder feels the entire navigation structure is fundamentally flawed, they will hesitate to say so. They don't want to destroy the masterpiece.
They feel bad.
Yeah. They will offer minor, superficial critiques instead.
Like, they'll ask to make the logo 10% bigger instead of pointing out that the checkout flow is entirely broken.
Precisely. But a prototype, especially one built in a tool like Balsamic, that deliberately renders shapes to look like wobbly hand-drawn sketches, signals psychological safety.
Right.
Its inherent roughness communicates that the design is cheap, it's malleable, and it's entirely unresolved. It practically begs the user to tear it apart. By intentionally keeping the fidelity low, you extract the high-value, brutal honesty required to find structural flaws before writing a single line of code.
That concept, that an intentional lack of polish actually yields superior business intelligence, is just phenomenal. And it perfectly sets the stage for what is arguably the most humbling phase of the entire process: usability testing.
Humbling is definitely the perfect word for it. Usability testing is where the designer's theoretical assumptions violently collide with actual human behavior.
It's the reality check.
It involves observing potential users in a controlled setting as they attempt to complete specific tasks using the prototype or a near-final design.
And the source material distills this phase into the 5 truths about usability testing. And I want us to unpack the mechanics behind every single one, because they really challenge a lot of assumptions about expertise.
Let's do it.
Okay, truth number 1. It reminds designers that they aren't the user.
This directly addresses the curse of knowledge.
Right.
When a designer spends 3 months architecting a system, they possess a perfect encyclopedic mental model of how the underlying logic works. They know exactly where the settings menu is hidden because they put it there.
Of course they do.
But a first-time user does not share that mental model at all. They are interpreting the interface purely on surface-level visual cues.
It's like the designer is looking at the code of the matrix, but the user is just looking at a flat screen.
Exactly.
Yeah.
And usability testing brutally exposes that disconnect. It is a stark reminder that your intimate knowledge of the system actually disqualifies you from accurately predicting how a novice will interpret it.
Wow, okay. Which leads to truth number 2. Testing a little is better than nothing. The text claims that testing with even a single user will reveal unseen problems. Now, I have to push back on this from a data science perspective.
Okay, go ahead.
If I test a prototype on literally one person and they stumble on a navigation pattern, isn't that just a statistical anomaly? How can you possibly justify altering the core architecture of an application based on an N of 1 sample size?
That is the most common objection from mathematically minded stakeholders.
It seems illogical.
I get it. But you have to separate usability testing from market research. If you want to know if users prefer a blue interface or a green interface, yes, an N of 1 is a useless anecdote. You need statistical significance for preference. But usability testing isn't testing for preference, it's testing for friction.
Okay, map that out for me. What's the difference?
Think about physical architecture. If you install a glass door in a building, and the very first person who walks up to it assumes it's a push door based on the handle design, and they literally smash their face into the glass because it's actually a pull door.
Ouch.
Yeah. You do not need to watch 99 more people smash their faces to achieve statistical significance. The friction is absolute. If one user trips over a confusing cognitive leap in your digital interface, it is a guaranteed mechanical flaw. Others will hit it too. Finding one instance of friction is entirely sufficient to warrant a redesign of that specific interaction.
Oh, that completely reframes the value of small-scale testing. You are hunting for broken door handles, not surveying paint color preferences.
Exactly.
That makes truth number 3 self-evident. Test early, test often. Because the closer you are to the whiteboard sketch, the cheaper it is to fix the door handle.
Right.
If you wait until the software is fully coded to test it, repairing that friction requires massive engineering resources.
It becomes massive technical debt.
Yeah. Okay, truth number 4 provides a crucial boundary for this feedback loop. Testing helps inform a decision. This is vital. Usability testing is not a democratic process where the user dictates the design.
No, never.
Right, you don't just blindly implement whatever the frustrated user suggests.
Exactly. Users are world-class experts at experiencing problems, but they are generally terrible at prescribing systemic solutions.
Give me an example of that.
Well, a user might complain that a multi-step form is too long,
Right?
And they suggest you just cram all 50 questions onto a single page so they can scroll it. If you blindly follow that advice, you've just created an incredibly overwhelming UI that will cause massive abandonment.
It would look terrible.
Right. The designer's job is to observe the symptom, which is fatigue with a multi-step form, and use their professional judgment to engineer the correct cure, perhaps by introducing a progress bar to manage expectations. The testing informs the insight. The designer makes the decision.
I love that. The testing informs the insight, the designer makes the decision. And finally, truth number 5 acts as the ultimate equalizer. Reaction from a real user trumps everything.
The text states this beautifully. It says, no amount of research, data, or design knowledge will ensure that a given design will be successful. Until people actually use the website, everything is based on thoughts and assumptions.
That is heavy.
It really is. You can have a team of highly paid UX architects who follow every best practice in the industry. But if a real human sits down and fails to complete a transaction, the theoretical knowledge is completely irrelevant. Reality always wins.
So, assuming your design has survived the gauntlet of usability testing, right? The prototype flows, the friction is minimized, the mental models align. It is time to finally pour to concrete. We enter the construction phase, user interface development.
This is the critical handoff. A front-end developer, also referred to as a UI developer, takes the finalized visual design and uses it as a literal construction schematic to write the code.
Okay.
This code serves as the translation layer. It connects the visual interface that the user interacts with to the incredibly complex back-end databases and server processes that actually do the heavy lifting.
So they're basically building the interactive skin that protects the user from having to understand the underlying machinery.
Exactly.
The source material outlines the specific languages and technologies used to build this layer. Let's look at the foundational architecture, starting with HTML.
HTML, hypertext markup language. It is the absolute bedrock of the web. But it's important to understand what HTML actually is.
What do you mean?
Well, it is not a complex programming language that handles deep logic or mathematical computation. It is a markup language. It is primarily concerned with structure and semantics. It uses tags to tell the browser, this is a primary heading, this is a paragraph, this is a link to another document.
Okay, so it's the framing of the house. It dictates where the walls and windows are, but it doesn't care what color they are.
Precisely.
The text specifically highlights HTML5, which revolutionized the capability of the browser by natively supporting multimedia like video and audio without requiring users to download those clunky, highly vulnerable third-party plugins we all remember.
Oh, the dark days of plugins.
Yeah. But if HTML is just the structural framing, how do we make the interface actually look like the polished design? That is where CSS comes in.
Cascading style sheets. The separation of HTML and CSS is one of the most brilliant architectural paradigms in computing history.
Really? Why is it so brilliant?
Because CSS handles all the presentation, styling, and formatting. It dictates the typography, the colors, the grid alignments, the hover states.
But why is that separation so critical? Why not just put the styling code directly inside the HTML structure code?
Because of scalability and maintenance. Imagine you have a massive enterprise application with 10,000 distinct pages, and the marketing department decides to change the primary brand color from blue to purple.
Okay.
You do not want to open 10,000 individual HTML files to update the color code manually.
That would take weeks.
Exactly. With CSS, the styling is abstracted into a separate style sheet. The HTML structural elements simply point to the CSS file for visual instructions. You change the hex code for the color in one single line of the CSS file, and it instantly cascades across all 10,000 pages of the application.
Hence the word cascading. It allows the visual layer to be entirely fluid while the structural layer remains rigidly stable.
Yes.
The text also mentions Java as a scripting language for creating web applications, but the technology that I really want to dissect here is AJX.
AJX is the mechanism that transitioned the web from a static library of documents into a landscape of living applications.
Okay.
It stands for Asynchronous JavaScript and XML.
Now, to understand why AJX was a massive psychological leap for UX, we have to remember how the web used to work.
Right.
In the early 2000s, the web was essentially a document retrieval system. If you were looking at a page and you clicked a button to, say, add an item to a shopping cart, the browser had to stop everything.
Everything stopped.
The screen would go white, it would send the request to the server would process it, and then the server would send back a completely new HTML document to redraw the entire page from top to bottom, just to show a little number 1 next to the cart icon.
It was a fully synchronous process.
Yeah.
If we connect this to the bigger picture, you request, you wait in a void, you receive. It severely interrupted the user's cognitive flow and made interacting with complex interfaces incredibly tedious.
So how does AJX change that interaction model?
It breaks the synchronicity.
Oh.
Think of AJX like a highly efficient sous chef in a kitchen.
Okay, I like food analogies.
But for AJX, if the head chef needed a specific spice from the pantry, the entire kitchen had to stop cooking, walk to the pantry together, get the spice, and walk back.
Very inefficient.
With AJX, the head chef, the browser, keeps cooking the meal. The user continues to interact with the interface. Meanwhile, the sous chef AJX runs to the pantry in the background, grabs the exact piece of data needed, and brings it back to update just one tiny specific element on the screen.
So practically speaking, when I click like on a social media post, the page doesn't reload. The heart icon turns red instantly, and AJX is quietly communicating with the server in the background to log the data without interrupting my scrolling.
Exactly. AJX allowed for the immediate processing of user requests by transferring small packets of data asynchronously. It is the engine behind infinite scrolling, live search suggestions, real-time dashboard updates.
Wow.
It made web applications feel as fast and seamless as native desktop software.
This combination, the semantic structure of HTML5, the scalable presentation of CSS, and the asynchronous data flow of AJAX provides an incredibly powerful toolkit. But as we move into segment 7, the text introduces a massive paradigm shift that completely upended how we deploy those tools.
The mobile revolution.
Yes, because we are no longer guaranteeing that the user is viewing this complex architecture on a 24-inch monitor while sitting comfortably at a desk. We all carry the internet in our pockets now.
And the advent of the smartphone triggered an existential crisis for UI design.
It really did.
The text points out that mobile UX is no longer a secondary consideration or a novelty. It is the absolute forefront of digital interaction. Users expect parity in functionality, but they will absolutely not tolerate a desktop experience crammed onto a small screen.
The book quotes a design mantra from Nokia that perfectly encapsulates this pivot. It says, "Don't shrink, rethink."
Yes, you cannot simply take a complex, dense desktop interface, scale it down mathematically by 80%, and call it a mobile app.
Yeah.
The physical interaction model has completely changed, and the environmental context has completely changed. You must completely rethink the cognitive load of the experience.
The source material provides several rigorous tips for mobile design. First, you have to ruthlessly prioritize. You just cannot fit a massive mega menu on a phone. You must feature only the key functionality from the desktop experience.
Right.
But it also suggests something interesting. It says you should offer mobile-only functionality.
This is about leveraging the unique hardware of the device.
Okay, like what?
Well, a desktop computer doesn't easily scan a QR code or track your precise GPS coordinates while you physically walk through a retail store. A mobile interface should strip away unnecessary desktop bloat, but it should also introduce specific contextual tools that are only possible because the user's holding a camera and a GPS receiver in their hand.
That makes total sense. But the most critical tip, however, addresses the biomechanics of how we actually navigate these devices. The text states that because navigation is completed through touch, and because a finger isn't as precise as a mouse, larger click targets are absolutely necessary.
This is a practical application of Fitts' law, which is a fundamental principle of human-computer interaction. Fitts' law dictates that the time required to rapidly move to a target area is a function of the ratio between the distance to the target and the width of the target.
Okay, let's translate that into practical UI. Because if I just think about it, isn't a finger just a built-in mouse? Why do we have to design differently for touch?
Well, a mouse cursor on a desktop operates with pixel-perfect precision. It's an infinitely sharp point.
Right.
Because the cursor is so precise, you can pack incredibly dense navigation links closely together, and the user can easily click the correct one. But when a user transitions to a mobile device, the precise laser of the mouse cursor is replaced by a blunt instrument, the human thumb.
The contact patch of a thumb pressing on a glass screen is massive compared to a single pixel.
Exactly. If you design a mobile interface with the same dense spacing as a desktop interface, the user's thumb will overlap multiple interactive elements simultaneously.
And the phone just guesses which one you meant.
Right. The system won't know which link they intended to tap, leading to massive frustration, erroneous navigation, and immediate user abandonment. You have to design larger touch targets, and you must introduce significant negative space between those targets to accommodate the imprecise physics of human anatomy.
It's the reason you see those big, chunky buttons spanning the entire width of your phone screen at the bottom of an app. It's not just a stylistic trend, it's a literal ergonomic necessity.
Absolutely.
The text also emphasizes the need to optimize for speed, because cellular networks can be incredibly volatile compared to desktop broadband. But it also notes a psychological factor, which is that mobile users are highly distracted.
The environmental context of mobile use is basically chaos. A desktop user is generally stationary and focused. A mobile user might be walking down a crowded sidewalk, holding a coffee in one hand, navigating your app with their thumb, while simultaneously scanning for their bus.
Right, their attention is totally divided.
Their cognitive bandwidth is severely compromised. If your interface requires intense concentration or features complex, multi-layered navigation, the distracted user will fail to complete the task. The UI must be radically simplified to account for environmental distraction.
So how do we engineer a systemic solution for this deeply fragmented landscape? Because we have users on 27-inch desktop monitors, 13-inch laptops, 10-inch tablets, and 5-inch phones.
It's a nightmare for developers.
In the early days of the mobile web, the solution was just brute force. A company would build their main website, and then they would pay a development team to build an entirely separate, stripped-down mobile website, usually hosted on an m.dot subdomain.
It was a maintenance nightmare. You had two separate code bases, two separate content repositories, and you were essentially trying to guess which device the user had. The modern architectural solution to this problem is responsive design.
Responsive design. That's the concept where a single, unified website automatically responds and adapts to the environment and the behavior of the user viewing it.
Yes.
It's one set of code that looks perfect on a massive monitor and equally perfect on a smartphone.
It completely eliminates the need to build separate sites. It achieves this fluidity through a combination of flexible grids, scalable images, and primarily CSS media queries.
How do media queries actually work under the hood?
Remember how we discussed CSS acting as the presentation layer?
Yeah, the paint on the house.
Right. A media query is essentially a conditional logic statement written directly into that CSS. When a browser loads a responsive website, the CSS actively interrogates the device. It basically asks, what is the precise pixel width of your viewport?
Oh, so the code is actively talking to the hardware?
Exactly. If the device reports a width of, say, 1200 pixels, the CSS delivers the layout instructions for a desktop. Display the navigation as a horizontal row, show 3 columns of text side by side.
All right.
But if the user shrinks their browser window or opens a site on a smartphone that reports a width of only 400 pixels, the media query triggers a completely different set of instructions.
What does it do?
It instantly collapses the horizontal navigation into a hidden hamburger menu, and it stacks the 3 columns of text vertically, so the user only has to scroll down rather than zooming and panning side to side. The structural HTML remains identical, only the CSS presentation adapts.
Wow, it is an incredibly elegant solution to a chaotic hardware landscape. So what does this all mean? Let's pull all of this together and look at the immense journey we've tracked today from Chapter 15.
It's a lot of ground to cover.
We started with the sheer psychological empathy required in user research understanding that to build a functional system, you have to observe a human struggling in their natural environment to uncover the friction they can't even articulate.
We then translated that complex human behavioral data into deliberate low-fidelity constraints. We used the architectural blueprinting of wireframes to strip away aesthetic bias, forcing stakeholders to confront structural logic.
Right. We introduced interactivity with prototypes, intentionally leaving them looking unpolished to create a psychologically safe space for brutal, honest feedback. We then subjected those assumptions to the humbling crucible of usability testing, recognizing that the friction encountered by a single real user absolutely overrides the theoretical expertise of the designer.
And finally, we explored how that deeply human-centric blueprint is translated into the strict logic of code. We saw how the separation of HTML and CSS allows for scalable architecture, how AJX revolutionized the cognitive flow of web interaction, and how responsive media queries mathematically morph that code to accommodate the distracted, imprecise nature of mobile touch interaction.
It is a phenomenal pipeline. And I think the most striking takeaway from this entire deep dive is the inherent paradox at the heart of digital design. We utilize incredibly sophisticated technology, asynchronous data transfers, dynamic CSS calculations, massive server arrays to build the modern digital landscape.
We really are operating at the cutting edge of computational capability.
Yet, the ultimate success or catastrophic failure of all that advanced engineering rests entirely on remarkably primitive foundations.
That's the provocative thought I want everyone to leave with today. Consider that paradox. It relies on the insight gained by sketching a wobbly box on a whiteboard with a dry erase marker.
Yeah.
And more profoundly, it relies on observing the raw, unpredictable, entirely analog frustration of a single human being trying to navigate the system you built. Technology will continue to scale and accelerate, but the architecture of the digital world remains permanently tethered to the messy reality of human psychology.
You cannot code your way out of a lack of empathy. That is a brilliant place to wrap this up. Thank you for navigating this complex intersection of psychology and architecture with us.
It was a pleasure.
If this deep dive changed how you look at the apps on your phone, hit that subscribe button so we can keep untangling these invisible systems for you. And if you want to dig deeper into the actual mechanics and visual examples we discussed today, grab a physical copy of Graphic Design Reference plus Specification by scanning the QR code on your screen or clicking the link right below.
Definitely check it out.
The next time a website instantly adapts as you rotate your phone, or a form updates seamlessly without reloading, take a second to appreciate the rigorous research, the wireframes, and the asynchronous code that manufactured that moment of frictionless magic. We will see you on the next deep dive.